Yo, what's up, everybody? I just finished talking to some students and closed that out. And so here we're back running a little video talking about the second part of the lecture test. Like I said, for those of you who maybe didn't watch the first one, the reason why I keep looking off to the side is not a person, holding me at gunpoint, but I'm actually looking at another screen that has the test on it and looking at some questions about the immune system. Um, Let me say this about the immune system. You kind of have to look at the immune system as from several different standpoints. All right. Number one, you need to realize that the immune system has innate immunity, and then you've got active immunity. And this innate immunity is, made up of things that may or may not attack. They more like block, distract, maybe destroy things, but they don't have a memory. They don't adapt to whatever the pathogen is that they've encountered. So they don't do that. So things like your skin or mucus or your tears, they don't adapt. Your mucus doesn't say, "Oh, look, that's that cold we got back in '89. Let's jump on them." That's not what innate immunity does. Innate immunity is great. Don't get me wrong. Innate immunity is like a wall or a locked door or barbed wire or it's something like that. So it can protect you. It's great and it does protect you. It works. It just doesn't have a memory. So it doesn't remember the pathogens that it kept out or the pathogens that it attacked or the pathogens that, attempted an invasion versus adaptive immunity. That's adaptive and active immunity. That's different. Those cells actually develop a memory. They remember what you attack and they formulate what we call your immunity, which, if you're going to have immunity, you have to have one thing that has to happen. I don't care what else any textbook or anybody else tells you. There is one thing that is very key to make immunity happen, and that is exposure. If your immune cells are not exposed to the pathogen, you will not create an immunity. I mean, somebody has to come into contact with the pathogen in order to make up a viable defense, and that's extremely important. So, in the process of creating immunity against a particular pathogen, you're going to notice that every process it always begins with an encounter with the pathogen. Like, for example, the textbook shows a regular body cell. It's just a random body cell. They don't even say what cell it is. It's just a random body cell, and it shows that body cell get infected by some type of viral pathogen. And then once it's infected by the viral pathogen, the image in the textbook in chapter 22 displays the cell taking a fragment of a peptide from this not destroyed, but from this viral agent. And it takes that peptide and it displays it with a class 1 MHC protein. Now, when it displays that peptide, it's displaying that peptide a lot like a billboard. Um, there was a movie series with Bruce Willis in it. And if you guys are like millennials or whatever, you probably don't remember this unless you're an older millennial. There was a action movie series called Die Hard, and I think there's like 4 or 5 of these movies: Live Free, Die Hard, and all those things. In the very first Die Hard movie, Bruce Willis's character gets trapped in this building with these terrorist dudes, right? And he's trying to get the attention of anybody who can come by the building so that he can get help. And he winds up getting the attention of one cop that believes him, but he winds up getting attention because he's putting stuff in the window. And he does some really crazy stuff. Like, he even makes an explosion that really gets people's attention. By him putting that stuff in the window and all that stuff, it's a signal to everybody that, hey, there's something going down in this building. You need to help them. Yippee-ki-yay. All right. If you see the movie, you know where that yippee-ki-yay part comes from. I'm leaving out. You're leaving out the last part of that too. We'll keep this video PG. So anyway, that's what your normal cells do. They'll put a class 1 MHC protein on the surface of the cell as a signal to other immune cells to tell them, hey, this cell is infected. mark this dude for deletion along with the pathogen inside of it. That's why in the textbook, when you look at the picture of the cell that's displaying a class 1 MHC protein, that cell winds up getting destroyed. He gets wiped off the planet. He gets nuked. For those of you who played Resident Evil, you know that's a common theme. Let's mark this city for deletion, Raccoon City, and let's nuke it. So the same thing happens with infected cells. Now, a class 2 MHC protein, that's different. A class 2 MHC protein is a marker that we place on cells, on immune cells. And these are cells carrying around that peptide on that protein marker on its cell surface so that they can communicate with other white blood cells to tell them about, hey, this is what I found. We need to establish immunity against it. The problem is that in order to establish immunity, you have to be exposed to the pathogen. So they expose one another to the fragment of the pathogen in order to stimulate activation and then replication of these cells, who will then ultimately lead to you establishing immunity. And remember, you don't really have immunity until you have had exposure to the pathogen, and then you create memory cells, and then ultimately your B cells turn into plasma cells, and they produce antibodies. So those are things that are key to remember. I'm shortening that whole process a whole lot, and I can go into more detail with some more videos. And if you've got some more questions as well, just go ahead and shoot them to me via email, or you can post them in the discussion board, and I can take those questions from there as well. But that's very key. If you read the list, I'll talk about the difference between humoral immunity and other types of immunity. Humoral immunity is referring to when you make antibodies. Humoral, also known as antibody-mediated immunity. Humoral immunity happens when B cells are stimulated and then they're activated and they become plasma cells. And once they become plasma cells, they make antibodies. And once you have antibodies, these proteins can be used to attack and immobilize and destroy pathogens, whereas cell-mediated immunity is primarily T cells, and that's when things like cytotoxic T cells tag a cell for deletion and destroy it. And so cell-mediated immunity is cell-to-cell combat, while humoral-mediated immunity is antibody-mediated immunity. That's long-range missiles firing at a pathogen. Some other things that you want to look at is you want to definitely know the different white blood cells. What do basophils do? What do macrophages do? What do neutrophils do? Eosinophils, natural killer cells. Basophils do not attack anything. Please don't tell me that basophils attack, because they don't. Basophils, what they do is they're cousins of mast cells. They produce things like histamine, and they cause an inflammatory response. Whereas macrophages, those are giant cookie monster type cells. They engulf pathogens and engulf debris, and that's how they destroy pathogens. Now they engulf the pathogens, they destroy the pathogens, they display class 2 MHC proteins and fragments from the pathogens, but they don't create antibodies or proliferate or have a memory. They just eat stuff. They don't remember it. Neutrophils, those dudes are all about destroying bacteria. So if you have a bacterial infection, the cell that I expect to show up on the scene immediately are neutrophils. Eosinophils, their claim to fame is they like to attack parasites. They are very key for attacking parasites. That's why you have such a small percentage of your blood cells as eosinophils, because they attack parasites. Natural killer cells, these are NK cells. These cells are still kind of recently discovered. We didn't discover them until the 70s. The reason why we call them natural killer cells is we gave them that as a nickname. It was during the George Romero era, when Night of the Living Dead and zombies and stuff, and we saw these cells that were just eating people's cells, just destroying them. And we thought we had discovered some type of infectious pathogenic agent from a horror movie. And they actually kept it a secret. They didn't tell anybody what they had discovered until they actually found out that, hey, these natural killer cells are actually white blood cells, and they are destroying cancer cells and other infected cells. That's what these cells do. But they don't have a memory. So they're great to have. They destroy cancer cells, but they don't have any memory of it. Therefore, you don't get immunity from them. Make sure you go over what an antigen is and what an antibody is. Remember, an antigen is not bad. An antigen is nothing more than a license plate on a cell. It just helps us to identify self from non-self. So antigens are like a license plate. They tell us exactly where that cell came from, versus an antibody, which is a protein that we use to lock on to rogue antigens and destroy those rogue antigens or those pathogens. One last thing, make sure you go back and you look at the role of a helper T cell. Helper T cells do not attack things. Okay? Remember that. Helper T cells do not attack anything. All they do is they just label what's there as they're kind of like dispatch. Helper T cells help to communicate with other immune cells to tell them that there's a problem. That's what a helper T cell is. And that's why the AIDS virus, HIV, that's why it's so deadly and so brilliant at the same time. The HIV virus actually targets helper T cells to take them out of commission, because if you don't have helper T cells, then helper T cells can't tell your other immune cells when there's a pathogen around and when you should have an immune response. And that's why people who have AIDS and the HIV virus, they ultimately wind up being susceptible to dying from a common cold, because your immune system can't work. All right, that's all I have now for that particular video. Tune in next time. We'll have some more videos loaded up for you guys shortly. We'll see you later.